Knurley is a Python app that reads a CSV file of named URLs and returns a listing of which names refer to the same, semantically identical URL. This is useful for my team at work, which maintains a database of named URLs we use to control what params are sent to Freewheel when requesting video ads to stitch into video streams served to customers. The goal is to prevent duplication of named URLs while also maximizing reuse of URLs. That simplifies and speeds subsequent updating or correcting URLs. The result URLs with reordered query string params are also useful by themselves, as visually scanning the URLs is made easier knowing the params are in order. This helps locate what params are present, as well as to identify which params are missing or unnecessary. The project expects the URL database to be available as a CSV file named testdata.csv. The getData function, called by main, opens and reads an entire CSV file, returning it as a dict. The process URL function parses the passed-in URL into the 6 standard pieces of a valid URL: scheme, domain, path, params, query string, and fragment. Then it parses the query string to alphabetically reorder the key values therein. Finally, it reassembles and returns the URL with its original scheme, domain, path, params, and the reordered query string and fragment. The process row, called by main as it iterates through the data dict, calls the process URL function, then hashes that result and appends a k to derive a non-numeric value that can be used as a dictionary key, then returns a tuple of the key, the original URL name, and the normalized reordered URL to main. The hashing of the URL to derive a key, which is then used to determine whether the URL is identical to an already processed URL, must be deterministic for 2 reasons. The PyTest assertion that process row cannot be furnished an expected result for the new key part of the tuple that functions returns, and subsequent runs of the project against an identical CSV file would not return the same result unless it was deterministic. For these reasons, I chose to use the MD5 component of the hash library, the result of which, when stringified, is deterministic and repeatable. The last step of the main function is to assemble a dict-based mapping of keys, which are the result of hashing URLs and prepending with k to lists of multiple names that reference semantically identical URLs. Such mapping is hard to do manually and visually because the URLs can be very long and have as many as 80 parameters submitted by different users in different order. The project outputs a JSON file of the dict in which results are accumulated. This file will be used to create periodic reports about duplicates and could also be used to drive some automated process to remove duplicates and update code with a retained common name where a removed name was formerly referenced.